Hi all, my name is Omid, CTO at Jatomate, also the founder of this meetup, Big Data Demystified. Can you see my screen?
Yeah, we can.
Yes, okay, great. So 1 second, sharing, presenting. So this meetup today is about Airflow. It's about performance and best practices I'm implying while using Airflow. Notice this is a relatively advanced session, so should you have any questions which are about the jargon, about basic concept, please do not hesitate to stop me and ask questions as you need. About me, you should know that I'm more than welcome any challenges or any questions you may have. It's a discussion for me, not a pure lecture. So feel free to engage with me either during the meetup or after the meetup via my email or LinkedIn. Regarding our community, 3 years ago, I started Big Data Demystified. We have 3 different groups: AWS Big Data Demystified, which is only about AWS content; Big Data Demystified, which is the main group for all the content related to data; and a focus group for BI and analytics. About me, if you don't know me, I see there's quite a few new names today. 20 years in high-tech industry, a lot of startups around me. In my history, I like to do a lot of extreme sports. I have a black belt in Taekwondo. I've been practicing for 20 years. Practice some skydiving, and I like to lecture in my free time and contribute to the community as much as I can. So the story begins on each meetup. I like to say that a long time ago, everything was very simple. There were applications with 3-tier applications. You had the web, the API, and the operational DB, some data warehouse, some application processes, and everybody were happy. But then came big data and everything became much more complicated. And then came the cloud that blew our minds away. And then came the invoice. And on top of everything, we had to be cost aware as well. So it keeps going. It doesn't wait for us to keep up. And this is what the main motivation behind this meetup, behind this community. I recognize this need. And though there's a lot of meetups out there, I felt the need to share from my experience, and hopefully you'll enjoy from this lecture and experience. As a philosophy, I tend to talk about cloud best practices and big data methodologies combined, and for me, that is the best of breed. That creates a good data engineering practice. So today's agenda, we're going to cover from the basics. We'll talk a little bit about some of the architectures of Airflow. We're going to talk about some basic jargon just to be clear on the discussions going forward. If you don't miss anything, you understand everything I'm about to say. The discussion will be mainly about performance and the best practices I applied along the way. So a little bit about architecture. Up until today, I heard about 7 types of architecture for Airflow, even though it says 6. The 7th is managed service by AWS, but I still didn't cover it yet personally, so I didn't want to talk about it too much. You have the sequential executor, which is in non-parallel execution of operators. You have the local and the celery, for which we're going to focus on today. There's the Mesos and Dusk, and the GCP Composer, which is a managed service by GCP. Today we're going to talk about local executor and celery executor, mainly because most of my experience are on these architecture. I don't want to talk about things I haven't personally experienced in production. But should you have any questions, please feel free to ask. If I know the answer, I'll be more than happy to share with you. 1 second, please. There's a guy here who didn't stop his video. He's walking in the park. So a little bit about local executor. It's a basic deployment. You have database in the background, the RDMS part, and you have a web server. It's a web GUI. Some scheduler processes which are spawned, and some tasks. This is a production grade deployment. You can use it in production, and you can run parallel tasks. And there's no need for broker here, which we'll talk in the next architecture. The only thing, it requires MySQL or Postgres or any operational DB you're familiar with. I prepared some sort of how-to blog about the different steps. Should you inquire about the different steps for installation? It's not the agenda for today, but just, so you'll have some, in essence, how simple it is to install it. Celery executor is quite similar to the previous architecture. The only difference is you have worker nodes on the right. You have the main node that holds the web server and the scheduler. You have some broker, for example, Redis that could hold as a queue. You have worker nodes, so you can scale out your cluster should you have any scale issues. Another jargon we should talk about is the dynamic operator. We have a full use case example here. By the way, all our content is uploaded to our website for free. There's no commercial issue behind it. Just log in, it's just my personal blog. All the content is uploaded to our YouTube channel. You can access it freely after a few days after the meetup. So you have here some sort of blog which explains how you can do a dynamic operator for Doug in Airflow. The basic idea is as follows. Let me go back to the lecture. You do some sort of a loop, and then you access an operator by giving it a dynamic task ID, meaning you have a prefix, and then, for example, a temp date as a suffix. And for each iteration in the loop, you'll have implementation of this operator in the game. Meaning, if you have 3 days here, you should see in the graph view 3 operators. Dynamic DAG. Dynamic DAG is a DAG that is created on runtime. This is a bad practice from my experience. It's highly complicated to manage it. Although it looks like a perfect code and object-oriented and so on and so forth, when you apply data methodologies at scale, it becomes very, very, very complex to maintain it and to add new features and debug processes which are failing, especially if you didn't write them. So I see this in 20% of the companies I work with. By the way, I'm a consultant, so most of my examples come from projects with customers. So all the customers that the 20% that got lost during the Airflow installation had bad practice around this dynamic DUGs, too much abuse of this feature, and the code became so messy. They had 4 layers of abstraction. It was too complicated to understand what's going on. Airflow performance. So this is the main focus of this lecture. So should you have any questions, please stop me and let's talk. Basically, when you come to do some performance tuning on Airflow, there's 3 major bottlenecks. And the first 2 are the amount of operators, which is correlated to the amount of CPU cores you have in the entire cluster. For example, if you have 1 CPU, is there a question? Okay. For example, if you have 10 CPUs on your cluster and you're running 1,000 concurrent cores, you should understand that nothing is going to work as you expect. You will have delays, you'll have failures, you have cluster hanging, which is not doing anything, and this stuff. The second bottleneck, obviously, is on your backend DB. If you deploy a too small, too weak backend database, then the amount of connection will be, default connection will be too small, then naturally you will have delays because you're throttling the amount of connection Airflow can connect to the backend DB. The third bottleneck is correlated with the amount of worker nodes. The more worker nodes you have, the more locks you have on the backend DB, and the more logs you'll have to fetch. So this creates some stress, which results in CPU time and network time and disk IO and so on and so forth. Another thing you should be aware of when you do a cluster maintenance, that the default configuration is not good for all use cases. It's a safe configuration that's designed to work in most cases, but it's not always good. For example, the amount of max concurrent DUGs that can run in parallel. Even if you put the resources, sometimes you'll see the cluster is not utilizing that enough. Concurrent operators. Obviously, if you're bounded by the cluster to not go over 32 operators, then if you throw more resources at the cluster, nothing will happen. Same goes for max connection. If you use the default connection, which is, I believe, 10 connections, won't be surprised if each step of the data pipeline takes time in between operators. In extreme cases, I saw a cluster where an operator runs, finishes, and the entire cluster waits about a minute until the next atomic operation in the data pipeline starts to work. Another bottleneck in the configuration is usually around the scheduler. The max threads, the maximum amount of scheduler processes is usually 2. It's the default number. This is something you should increase carefully. Should you experience any backlogs or latency, you don't want to go crazy because each thread of scheduler requires 1 CPU core. So if you have a machine with 8 CPU cores and you put 16 scheduler threads, then you're killing your cluster. Timeouts. Again, it's a default setting. It's a very low number. And if you are using dynamic DUGs and dynamic operators, you will experience timeouts. And all you need to do is just increase the timer because the scheduler takes some time to pass it, especially if you're using a low amount of scheduler processes.
So I have a question, like what's the option is for like dynamic DAGs or dynamic tasks inside the DAG? Let's say I have a process which needs to check once a day if something new appeared, and based on that, let's say it's a table, create an additional process, additional task to run on.
So don't do it dynamically. Do the same thing, just not dynamic. Meaning, do one DAG that checks once a day, once an hour if something new happens. If something new happens, trigger a new DAG, which is not physical, it's static. Okay, that will be easier to debug and maintain.
Okay, so just separate the process into like two DAGs, one for checking and another for, okay.
For actual work and trigger the actual work when needed. Okay. Any questions on this slide? I know it's a very overwhelming slide.
Well, maybe
Please,
another
guys.
question is how to determine how much of everything you need. Like here is like we have operators and a lot of CPU cores, what's related to those. Like, is there a way to somehow calculate what sort
Yes,
of,
yes, I'm going to address that down the road in this lecture. Bear with me a few more slides, and if it doesn't answer your question, please reiterate your question. I will be honored to answer each. Okay? Great. Any more questions, guys, about this slide before I continue? Okay. So thank you, Julius. So I prepared some 5 minutes tuning blog, so it will be easier if you don't want to go too much into deep. Just go over these parameters in your Airflow CFG and just increase them gradually. Ignore the numbers here, just double the numbers, see how this affects your cluster, and so on and so forth, and don't increase it too much. This DAG, this configuration, for instance, I increased by a factor of 100 just to test an experiment for running 10,000 operators on a single machine. Do not expand it on that on production. So just to show you that these configurations are rather critical. Another thing you should look on is Airflow documentation, which has improved over the years and contains all the relevant configuration. For example, Alchemy Max Overflow over here. And they explain it relatively good. What is the different number and what you should do if you want to remove limitations and so on and so forth. How to get started. Julius, this is for you. The first thing you want to do is to apply some sort of monitoring, not Flower, which is the default monitoring that only shows you the default state, the current state. You want something that uses the statsd service within the Airflow that exposes metrics about the cluster, and you can track them over time. For example, if you're using AWS, you can go over these metrics, which are exposed by Airflow and the statsd. For example, I have the example here, sorry. For example, queue task, running task, and open slots. And you can monitor over time in your production to understand what is your data pipeline pattern. Are you spiky? Are you, do you experience some load on a specific time period? For example, every 30 minutes within the hour, you have a peak. Okay, so you have here around 80 operators per second. and most of the time you are below 50. Okay, and you are very fast to peak and very fast to go down. Meaning within 10 minutes, you're after your peak. You have open slots to ensure you have enough operators for peaks, for more jobs and so on and so forth. And another important one is the queue task. Whether you are using local executor or salary executor, you'll have always a state where tasks are queued before they run. So you need to ensure the queue is always going up and going down. If it keeps going up for more than a short interval, you have a problem. You probably have an open slots issue, not enough resources configured in your cluster, and so on and so forth.
But here, like, what would be the good practice if I have a lot of running flows from different people? Would it be better separate into different airflow clusters by, I don't know, group by something, or in the end of the day, keep them in one place, but give a lot of resources?
From
What
my
would,
experience, from my experience, you can definitely do that. Be very, very careful when you do that. Meaning, I prefer to have an Airflow cluster per environment, for instance, production, pre-prod, staging, QA, development, and not to separate the data pipeline. Why? Because when you put one cluster in production, you can easily put some metrics, monitor it, and understand what's missing. If it's cluster CPU cores, or some basic configuration, elusive configuration you missed. Okay. Usually, once you have monitor at least these three, you'll cover 70% of your problems. Okay. So once you understand the IO pattern, or say operator pattern, the scheduling pattern, sorry, more appropriate. Scheduling pattern of your data pipelines, it will be much easier to manage. You simply follow my rules of thumb in terms of CPU cores to operators. I will mention them in a second. And apply proper configuration carefully, experiment them. And within a few days, you should be able to be highly tuned and to get to a situation where you're configured to 128 operators per second, and you're not utilizing, you don't need more than that because the cluster is designed for peak, meaning a 128. I have a queue. Should I need more than 128 per second? And you can see that based on these peaks, I'm good. I'm more than covered. Okay, now let's talk about best practices. This is relatively more for beginners, but I tend to see these mistakes more and more on production clusters at customers, so I wanted to iterate them. First, you should know that there's a blog here where I wrote a little bit more in detail about each one, but oh, oh, one second, please. One, recurring job is a good job, meaning a job you can press, you can trigger it twice in a row. That means the data pipeline has been written properly then, because nothing will differentiate in your data lake, meaning there will be no duplications or errors or conflicts or whatever. Debuggable job. The problem is with data pipelines that sometimes they run in production, and even if they are written perfectly in terms of code, sometimes you get data input, which will break your data pipeline. So you need, in every step of the way, a debuggable option, meaning print to logs, meaning you need to have the exact command you used printed to log so you can experiment on that specific part of that data pipeline on the failed input and see exactly what went wrong in front of you so you can fine tune your debugging. So be sure that you keep in mind the fact that every data pipeline will break tomorrow. Right after delete. If you're using a data pipeline and you're doing deletes and insert, don't use a dummy operator in between. Because what happens is, if you're using a production cluster which is not tuned, you're running too many operators, you'll sometimes get stuck because you don't have an operator slot available to serve the insert. And you're stuck on the dummy after the delete. So there won't be an insert until the cluster is freed. So be sure to use dummy operators on non-critical points, meaning after an atomic operation from your perspective, that it really signifies a breakpoint in your data pipeline. The ability to go back in time. When you write a data pipeline, you have to ensure that the raw data you are using, which is transformed, will always remain the same. The idea is that if you write a data pipeline, after a few months you want to change everything, you have the source and you can rerun everything and overwrite your entire data lake. The way to do that is to use Airflow variables. You have the ability to configure in the database of Airflow via the GUI variables, for example, start and how many days to go back in time and so on and so forth. So please use that. Some troubleshootings and some best practices about architecture. My recommendations are as follows. For a local executor, use one powerful machine. How powerful? The amount of CPUs and configuration required to run all your operators at peak. The reason for that is a simplified debugging when all hell breaks loose. Meaning you have one machine, the cluster is operating on. You have a complex data pipeline that runs on a single machine. Everything is written to the same machine, all the logs, all the temporary files you're saving. It's all in one machine, so it's easy to debug and trace. Furthermore, it's the fastest deployment you'll ever have because it's one machine with one database, no queue in the middle, so everything will be in the shortest possible latency. And it's cheap. If you're wondering how good it is for your production, let's just say I made an experiment. I can run on 2,000 operators per hour on a single machine. So you shouldn't be worried about that. If you're worried about high availability, you can apply celery executors, which allows you to use several worker nodes, for example, 1, 2, 3, 4 worker nodes. But I highly recommend to minimize the amount of workers and make them powerful enough to support your peak. The reason for that, because each worker node will create locks on your DDP, which will in turn create a ripple effect of slowness in your entire production. I saw a lot of deployments which are based on containerization. I personally avoid it in 80% of the use cases. The reason for that is simplicity. Unless you are expert in Kubernetes and Docker, put it aside. Working with Airflow and data pipeline requires a lot of knowledge and a lot of experience. So it's complex enough to give up the containerization issue. Instead, I highly recommend to create 3 separate environments: dev Airflow, staging Airflow, and production Airflow, which everybody can use, and it will make your life easier. I
But
don't mind.
a question here. How do you move between dev, stage, and production? I mean, you develop
Yes,
something, then you want to push it into staging, and then
yes,
after it proved you want to push it to prod, but you want to make a process kind of simple, because a lot of people, at least in my case, working with Airflow. So
yes.
what would be the recommendation how to do it easily?
Well, easy it will not be when you're working with many people and many Airflows and source code. So I can recommend what I usually do. I usually work with Git to test my code locally on a local Airflow deployment on my computer. Okay. And once I'm ready, I commit the code, use Jenkins to do some sort of CI/CD to move between environments and test them based on the use case on different environments. Naturally, you want to do some sort of automation to send alerts on Slack that you notify everybody you're going to override data and stay and so on and so forth. That depends on the amount of people in your team and your communication procedures and so on and so forth. But in most cases, in the 20% of complex use cases, this is more than enough. I hope this answers your question, Julius.
Okay, thank you.
Another question here. You were telling us about the power of a machine for the local executor. Could you give some numbers for the how powerful it would need to be, like to run
Yes.
thousands of executors?
In a minute, I'll give you one of the next slides. Will have a rule of thumb of how many operators per CPU cores you should hold.
Okay, thank you.
If it doesn't answer your question, please feel free to reiterate your question.
Thanks.
Thank you, Dimitri. So, where was I? Avoid containerization. Bootstrapping Airflow. Another problem with containerization is when you bootstrap an Airflow with no backfill control and improper code may trigger an entire backfill history. And each deployment of container may trigger a restart of the entire cluster, which may break a data pipeline in the middle. And this is not something you want to test. Okay, so you need to aim for clusters of Airflow which are 24/7 available, which kind of misses the point of containerization. Unless infrastructure as a code is a highly crucial requirement for you, strongly recommend to avoid it. The deployment is not very complicated. Upgrading is not very complicated. You simply need some sort of architect level skills to properly define the deployment, a DevOps ninja that will automate the procedure. It's not a big deal. So this is my recommendation. As a rule of thumb, for local executor, choose this architecture when you have less than 128 tasks per second. The reason for that is the ratio of operators and CPU cores. And we'll talk about that in a second. Celery executor, you should select when you have more than 128 tasks per second, or you have unexpected peaks, which may happen, or you go over month, and a queue will help, and you can add more machines each month instead of each month re-tuning your cluster. Regardless of your architecture, a monitoring of airflow metrics is a must, especially if your amount of data pipelines is big. You need some sort of eyes of what's going on. If a specific job is running late, if a specific job is taking longer each day and more than yesterday, and so on and so forth. The amount of operators per second may change over time. So these are things you want to track and to understand what's going on, especially if you are in a big team of data engineers. And this is for you, Dimitri. As a rule of thumb, you can go for each 4 operators, 1 CPU core in local executor. Meaning, if we talked about 128 before, you need 32 cores, which is a very strong machine. If you're talking about salary executors, since you have the scheduler on a different machine and the web service on a different machine, you can go up for 5 or even 6 in some use cases, operators per CPU cores. For simplicity, I highly recommend to avoid auto-scaling unless you're growing month over month, and then just add more nodes. Don't go up and down every hour. And if you're tuning, for example, max thread, increase it gradually. Don't go crazy. This will, especially in production, this can break your cluster. Same goes for timeouts. If you experience some stuck jobs in Airflow, this is the weird stuff that happens when everything is stuck. The machine is not working in terms of CPU metrics, but nothing is working. Sometimes because the parsing time of the scheduler is too short and it's causing timeout. So it's trying to parse it and aborts, trying to abort, trying and aborts, and consequently the data pipeline does not initiate. So consider the following. Sometimes it's a simple restart of Airflow. It had some garbage that needs to be disposed, and the restart will resolve it. Sometimes it's the amount of dynamic operators, dynamic components in your code is too big. For example, dynamic DAGs, and this takes a lot of time to pass, and the scheduler times out. So try to reduce the amount of dynamic operators, or try to increase the timeout. For example, DAG import timeout to 60 seconds, or DAG file processor timeout to 100 seconds, or when a scheduler becomes a zombie, give it 300 seconds instead of the default number, which is, I believe, 100. Worker is choked. Sometimes a worker is choked because there's a feature called subdag, which is a bad practice, by the way. When Airflow themselves removed this feature in 2.0, Airflow 2.0.
Why is it a bad practice?
The reason for that is that the subdag does not work concurrently on all the cluster. It only works on one node. So if a misfortunate worker gets this subdag, it's stuck with this subdag until it finishes, and it causes imbalance in your cluster in terms of working operators per worker. That means one machine might work too hard compared to the others. If you're on a local executor, it's not an issue, it's the same machine. But if you're working on a cluster, that may cause some bottlenecks on specific workers. In terms of CPU metrics, if you're familiar with the top metrics of Linux, if you apply my methodology for rule of thumbs of CPU metrics, you should not go over 4 times the amount of CPU cores as a top, meaning if you have 10 cores, do not go over top 40 in your machine. The reason for that, you will crash in production. As simple as that. Increasing monitoring interval to go see what goes on. Sometimes the airflow needs more time to send the logs via stat.d. So play with that, meaning send the logs on a shorter interval. So it will be easier to monitor in near real life, real time, what's going on in your cluster. Sometimes the queue is too long.
Sorry to interrupt. Short
Yes.
question about subDAG.
Please.
So it would be like, because it's kind of good for readability and not making DAG with tags.
It's good for readability.
Yeah,
it's
but
good for readability, but
then
not
it's
good
maybe
for
better to
handling.
move those subDAGs to DAGs and then like start one once another is finished.
Yes,
Like
yes, that's what I do. I use DAGs, not subDAGs, and trigger them. Okay, and I believe in Airflow 2 you have a new feature. I forgot how it's called. I think it's group task or something like that. Sorry?
It's task group.
Task group. Thank you for that. I don't know how to pronounce your name. I'm sorry. So
You can call me Joy.
thank you. Any more questions about this, Julius?
no, thank you. I'm clear.
Okay. So
I'm not sure I understand why not to use a subDAG in order to encapsulate and make the process more readable.
if that's your priority, do it.
Okay.
But bear in mind that Airflow themselves have removed this feature in Airflow 2.0.
And another thing, there is no parallelism of tasks in subDAG, like they run one by one.
Yeah, but in the subDAG you can make parallelism.
Perhaps, let's put it this way. Show me something you cannot do in my approach, meaning DAG of DAGs. Think about it a little bit. Perhaps you'll find comfort in my suggestion that will achieve both readability and performance aspects. But bear in mind, if you do not have performance issues, it's not an issue. That really depends on your use case. Okay, this is for, let's put it, let's call it top 500 companies in the world in terms of publishers that have a lot of data pipelines, and each hour they run several thousand operators and so on and so forth. You understand? Asaf?
Yeah, it answers my questions.
Okay.
Can I have a question regarding that?
Yes, just bear
isn't-
in mind that not always I see who is talking. Alexander, that's you?
Okay, yes.
Yes, please.
Isn't creating a DAG of DAGs be a bigger overhead than just creating a subDAG if it's not,
it is.
let's say,
Yes,
a
it is.
big process?
Yes, it is. That's why 2 options. One, consider what is most important to you, like I suggested to Asaf here. And second thing is to consider the task group feature on Airflow 2.0. I'm not familiar with that feature yet, but from all the use cases I encounter, the overhead is definitely worth it. Keep in mind that my perspective is usually stability. That every data pipeline when you come in the morning is green. Okay. So I prefer that over perfect code. Okay. Guys, feel free to stop me and interrupt and ask questions. This session is all about answering questions for you guys and helping you. So it's a discussion. Please.
So I have another question. It's about the best practices. Where exactly you put the data validation pipeline or testing your flow? We are gonna talk about it.
Not in this session, because this session is mostly about performance, basic mistakes people made in terms of stability and performance. But I will answer this question regardless of where we are in this lecture. What I usually do is apply data monitoring pipelines. And the two approaches you can do that. The first one would be within the data pipeline. Once you finish all your logic, apply, if you're using BigQuery, for example, an operator called BigQuery check operator that can accept true or false from your query. If you get false, then the operator will fail. And then you can fail your DAG. Then you can send a notification via Slack that something is wrong. If you want to be non-intrusive, you can apply a different perspective, which I prefer, is a different DAG for data monitoring, which checks everything you want to check in several layers, meaning sanity level, full regression, and so on and so forth. And this can go on and deeper as much as you like. You can do data quality issues on each day in the history, on the last 3 days. You can do basic validation, for example, if the day is not empty, or you can do highly advanced checks like anomaly detection on the amount of rows per partition, or you can do the anomaly detection on the actual value within a row, which is highly complex, but sometimes you have no choice. It depends on your use case. Should you have any follow-up questions, let's talk, and I'll be happy to provide more insight on that. Okay. So sometimes the queue is taking too much time. So the way to solve that is by increasing the max thread. Again, if you're using the default setting, you should have 2 schedulers, but if you're using 8, sometimes more often than not, your queue will reduce by order of magnitude. Sometimes it's a matter of heartbeat. All you have to do is decrease the amount of timeout for the job heartbeat and the scheduler heartbeat. Sometimes the problem is the amount of connections for the SQL backend database. So all you have to do is set up 2 unlimited connections, which is a bit funny that this is 0 and this is -1, but according to the documentation, this will get you unlimited connection. The risk here is on peaks that you can overwhelm your database. So bear that in mind when you're doing that in production, that this is an undesired side effect. Thus, the database must be strong and completely idle all the time. So if your database is spiky and reaches over 80%, say, on a regular basis, then your database is not strong enough. So be advised, do not use this without careful monitoring. Parallelism. You have several parameters to configure. One is this one, which is on a cluster level. Put a 128, and your cluster is tuned for 128 operators. However, the amount changes when you're talking on DAG level. 64 DAGs in parallel is the maximum amount of jobs you can run in parallel. The same applies for the same several instances of the same DAG, meaning one DAG running 10 times. So you have to be very careful about this. If you are talking about working concurrency, there are two parameters. One is worker concurrency, and one is worker autoscale. Be advised, you need to change both if you want to achieve 40 operators on this worker. Missing log. Sometimes you go to a worker, you press log, and you see nothing. It's only a problem of timeouts from the master node fetching the logs. So just increase it, double the amount of time, and this should be resolved.
Hi, I got a question on the previous
Please.
slide.
Yes, sir.
So log fetch timeout, does the timeout while master is trying to fetch the logs from the worker node, right? So it is ideally first it is trying to fetch from the scheduler node. If it is not getting from scheduler node, it is trying to fetch from the worker, right? That's right.
Yes.
And this 30-second is like if scheduler node, if we are not able to fetch the logs from the worker within 30 seconds, it would time out. Does that mean that?
Yes.
But in my case, I have encountered this issue. It is not taking even 15 seconds and it is timed out. Though I have set the log fetch timeout second as 30 only, but it is just failed within 15 seconds.
So first of all, it didn't happen for me after I increased the log fetch timer. So I would check two things. One is the utilization of that worker. Two, network issues. Check if
So
there's a problem on the network fabric.
So the problem I encountered is, so the log fetch happens via task instance, right? So from task instance, it is getting assigned a host name.
Yes.
So when I check the database, it doesn't have the task instance like host name at all in the task instance table. So I think that's a problem.
Then it may be another elusive configuration I'm not aware of. Try to check the amount of connections for the database. If it's unlimited, maybe there were too many locks on a specific table from the workers, so nothing happened on time. Understand?
Okay.
When you have, say, 3 nodes, the amount of locks on your backend DB will be too much. You will monitor that, you see spikes by the thousands of locks per second. Okay?
I see.
So check the DB angle, check the locks, check this configuration, and maybe everything will be aligned. I'm guessing here,
I'll
yes?
probably try. Otherwise, I'll bug you.
Okay, do bug me.
Sure, thanks.
Another question regarding the database, the backend database. You mentioned that you expect that, not expect that Airflow expect the database be idle or available all the time.
No, Airflow doesn't expect it. I expect it.
Okay, what happens? We're working with the database on a cloud environment, and our database sometimes get Google Cloud.
Google Cloud, you're using Cloud SQL?
MySQL, yes. We're using MySQL on Google Cloud, and it's pretty powerful database. But it's sometimes we have queries that they just not the stack, but they block everything because we're importing data into the database, and like everything stops. So
wait, stop there. Are you importing data into your Airflow MySQL DB?
Yes, because we technically using the same database for like, okay, same cluster, not the same database. Database is different.
Wait, let me be very clear. For the Airflow cluster, there is a backend DB, correct?
Right.
Are you putting data which is not relevant to your data pipeline?
Where to the database of the backend DB? Yes, we are using like okay, there is a cluster, right? There is like, not a cluster, there is a MySQL instance on cloud.
Yes.
We separate the databases inside the instance for the Airflow and for the rest of the data. So Airflow has a separate name,
Instance.
database name,
A
a
separate
separate
instance.
name on the cluster. It's not an instance. No, it's
Then
not an
separate the
instance.
instance. Don't do this.
Okay.
This will cause you huge amount of pain.
Okay, so you suggest to separate the instance so that okay, so that backend for Airflow will be completely separated, independent. Nothing will stack
Yeah.
and nothing will interfere with their work. Okay.
Imagine, just imagine what you just did for my example. Let's imagine I put an application on production and I let your application write to my database.
Okay, yeah, I understand the
Create
example.
undesired side effects.
But technically, like logically, we separate the data, but not physically. Like the instance is the same, but the database are different. So
Then do it
logs
physically.
supposed to be different, but they okay.
You
And how
split the
critical?
monitoring metrics.
Mhm.
You want to know where, again, this entire conversation evolves around the fact that you may have performance issues in your cluster. If you don't have any, there's no discussion. Everything flies.
Okay.
But
Yeah, right now we could have like we don't experience many, but we could have like right now I'm shooting in all directions to see what we can optimize. If like right now we don't really have an issue, but we could have.
What is your velocity? Are you going month over month on a regular basis?
With the amount of data to be processed by DAGs, yes.
Then you should expect problems.
Okay.
Okay, unless your velocity is stable. Sorry, the zooming stable, flatline, and there's no growth.
No, it's a slight increase. We're not very overwhelmed with the data, but it's a net increase. We have like a okay, it's a
okay. Let's put it this way: money-wise, cost perspective, there's no reason not to do so. The cost is not very high. You can take the cheapest MySQL Cloud SQL on Google. It will cost you about $20. You need to increase it, double it. It will cost you $40. There's really no cost issue to separate it.
okay. Yeah, I got it.
Okay?
Thanks.
Okay. You're welcome. Any more questions before I proceed, guys? Okay. Missing logs, we talked. Unpredicted peaks. So if you have unpredicted peaks on a regular basis in your use case, just use Celery Executor. So you will have some sort of a broker in the middle that will ingest the amount of requests, hold them in the queue, and release them based on your cluster capacity of open slots. Another thing you can consider, though I highly recommend to avoid it unless you really know what you're doing, is to do some sort of queue management. Alpha has a queue management for high and low priority queues. I highly recommend to avoid it because it's really hard to anticipate what will happen in terms of order of execution. And the other advanced technique, I never used it. I read about this. Should you have very large number of operators per second, and I'm talking about within the thousands per second, you can change the Celery pool type, which will in turn reduce the load on each CPU core. Okay, there are many types. There are like 3 types. You can read this article. It's quite knowledgeable. I personally haven't tested it, but I wanted to put it out there to you and encounter such a problem that maybe you will share from your experience. So unless you have any questions, I would like to summarize. I want to reiterate the question some people ask me why Airflow, even after this
I have
discussion.
2 questions, if possible.
Please, Alex.
One
Alexander.
regarding the dummy operator that you've been talking about in the beginners.
Yes.
In the beginner slide, you said something, don't use dummy operators between delete and insert. What do you mean between the
Imagine a
delete and insert?
pipeline that has a loop of delete, insert,
Delete the actual query, like an actual
delete
query of
data from
deleting.
table, and then insert the new data. For example,
Okay,
delete today's data because data from the last hour has been added and you want to refresh today's data. So delete today, add today. So some people make the mistake by doing delete, putting a dummy operator in the middle that says, now I deleted, I'm ready to insert, and then they insert data. So this by itself is not a problem unless you're running this within a highly busy cluster. You may end up in a situation when you get to the dummy, run it, and then you don't have enough open slots to do the insert. So you deleted the data for everybody, and now you're waiting for open slots to insert data. So that's an issue.
okay, I understand, yeah.
Another
last
issue
one
around
is-
data, well, allow me just to
Yeah, of course.
fine-tune another point. Imagine this delete dummy insert within a loop, running 1,000 times. So you're running 3,000 operators instead of 2,000. Imagine how many CPU cores you just wasted based on my matrix. Understand? Then your second question, my friend?
Where can we get the entire slide with the links and stuff that you?
I will post it once I'm done. If you're
Okay.
a member of this community and you RSVP yes to this meetup, after a few days, we upload the video and slides to our website, Big Data Demystified, which I showed. Allow me to reiterate this. Going to be here under data engineering, Airflow. All the past meetups and blogs are also here. Some examples committed to give, and just have fun.
Thanks.
You're welcome. Any more questions, guys?
Can you say anything about the Airflow alternatives and what's the advantage of Airflow? And also how it compares or relates to data science like ML flows and related
Yeah. I didn't prepare an answer for that, so let me freestyle this one. Yeah. First of all, this is an excellent question. People ask me that a lot, but really depends if you're willing to pay for this tool or not. For example, I'm not trying to sell anything, but be advised, I'm a consultant, so I consult. For example, Rivery, it's a really nice tool, okay? Not cheap one, but what you can do is with this one, you can integrate many source and many targets. For example, if you want to connect to Amazon Redshift, you just put the IP, user password, next, and you can do a simple data pipeline from any source to any target, or at least all the common ones. This will replace your Airflow cluster completely, but you're paying for this. So you need to understand, one, if you're willing to trade your effort in terms of development time and maintenance of Airflow cluster with a paid customer, with a paid solution. This is not the only solution out there. There are many. For example, Fivetran, and also common. For example, stitch. What's this the kind of stitch?
What about
Mm.
prefect?
Which one?
Prefect.
I'm not familiar with this one. Maybe it's an excellent tool, but I'm not familiar with this one. Stitch by talent, I believe. Stitch data. This one. Okay, you can read about this. Also nice tool. There's Supermetrics. Also nice tool. Some issues with the support, but a really nice tool. There's another one. Funnel. Relatively easy tool. Okay. All the known known APIs, for example, Google Analytics, for example, it's hard for me to consider, so let me just show you. YouTube, Google Analytics, Google Ads, Facebook. If you're working on a regular basis with all these publishers, content, analytic, marketing data, apps like by simple next, you can get all this data into your data pipeline, and it's relatively easy. Okay, so the question is, one, whether or not you're willing to pay for such a service, for a managed service. Second, is what is your use case? Meaning, sometimes your use case is straightforward, like getting your analytics data from YouTube. Sometimes your data pipeline is so complex because it's based on your application data. You want to customize your data pipeline, and you need to write code for that. And for that, Airflow will integrate relatively easy. The third question you had is regarding data science perspective. There are many things to consider while working with data scientists. Based on my experience, it's divided into two main issues. The first one is the data scientist wants a specific data pipeline, and he wrote the code, the SQLs, and he needs to transfer that to the data engineer to make the data pipeline comply with the best practices we make. For example, the recurring job, for example, the debuggable to go back in time, and so on and so forth, which the data scientist doesn't really take those things into consideration because he only cares about the data set, the sample data set. Another use case for a data scientist is the MLOps, where the data scientist creates some sort of machine learning algorithm and he wants this data to go to run experiments on different data sets. This use case entirely is not for Airflow. I mean, you could do it in Airflow, not recommended, been there, done that, it's a headache. Why? Because Airflow was not designed for that. For that, you have specific tools which were designed to do all the machine learning ops or operations and to manage experiments. We have them. We had them on meetup about them. In the last year, I believe. 1 second. This one. This meetup, you can read about this and see the video. No, not this one, sorry. This one, Superhero Team Up. Okay, this is an excellent meetup that talks about the life cycle of MLOps. It's by Allegro. It's a commercial company. It's a commercial Israeli startup. And you can go over this. The Erez and Ariel are very nice guys. You can talk to them. Go over the slides, see if this fits your use case. There are other tools I'm not familiar with all of them naturally. I'm only familiar with Airflow and this one, Allego AI. Does this answer your question, Louis?
Yeah, thanks.
Any other questions, guys?
Hi, Omid. Yeah.
Hi, Owen.
I have a few questions. So we talked about configurations and what you can do to tune the data pipelines, but I want to ask if you have like tips for dev teams, you know, in terms of code maintenance and versions and deployment.
Yes.
This is the
But
first question.
I didn't prepare anything, but I can freestyle it if you have a specific question.
I mean, how do you manage all the code between the
Git.
dev? If you have like large projects that you separate in for a dev team, how do you suggest to do it properly?
Yes. First of
And
all,
also I want to and the second question is if let's say we have like a very complicated DAG or a bunch of DAGs that you want to package to like a service or a product, and you just want to close it in a box and like an out of the box service that you can just go to a machine and do like pip install and validate all the dependencies and stuff, and how you suggest to do that?
This is a complex answer, and I will try my best to freestyle it. First of all, regarding the dev team pipeline, I really need to know more details about your specific use case to answer it completely. However, the common practice I apply on the 20%, not on the 80%. On the 20% of the use cases, which are complex data team, data engineering team, the complex data pipeline, is the following. 3 environments. 1, on your local machine for dev, you have a Docker container running Airflow, you are using Git, you're compiling your code,
No,
testing
we're
it.
not. We can't use Docker at this point. What we're doing is just replicating VMs using templates from production.
Good.
This
problem.
is what we do at this point. But we don't use Docker.
Don't use Docker. I hate Docker anyways, as long as you have a dev environment. So I take it you have a dev environment, correct?
We have lots of dev VMs, not just one dev machine.
Per developer.
We tried using only one dev machine and we ruined it a few times and we saw it didn't work.
It's
so
not feasible. It's not
Yeah.
feasible. You need an Airflow machine per developer.
Yeah, exactly.
For sure. It's not feasible. Then you create a QA environment if needed. Not always you need it.
Yeah, we
Then
also
you
have a
create-
VM for each tester.
Okay, no problem. That's also feasible. Staging. That divides into 2 scenarios. One is proper staging with staging data, and one is pre-prod, which is kind of like staging only with production data. Do you
Yeah,
understand
okay.
the difference?
Yeah, I do.
So I suggest to separate the 2 if you're complex, you have a complex use case, because staging is for integration, pre-prod is for data quality.
Okay.
Yes. And
Yeah.
there's a major difference between code development and data pipeline development. Data pipeline is all about data quality, not the other way around.
Okay.
You understand the difference? It's a major difference.
Yeah, I do, but I want to know how do you like take a large development and separate it to tasks in a team where you can work and not affect each other code.
Yeah, I don't have a really good answer for that. My answer would be each developer entire data pipeline. Don't do several developers on the same DAG. It will drive them crazy.
Okay, and what about we also created a few custom operators, for example.
Mm-hmm.
So this is for the second question. If I want to take a bunch of DAGs and close it as one service and apply it on a machine, and how do you think we should do that?
That's a third question. The second question was about complex DAG. Do you want me to address that first?
Okay, sure.
Complex DAG, avoid it as much as possible. The reason for that, the scheduler will work extra hard to parse it. You need to break it down to smaller pieces.
Okay.
They can all be connected, meaning one DAG triggers, for example, at midnight, and then on each step of the way, it triggers new DAGs and new DAGs until everything runs on the specific dependency you need. Okay? But
Okay.
do not put one complex DAG with few hundred operators within it. Will kill your cluster. Unless it's highly tuned, and it's usually not the case. The third question you had is about pip install. That's a common problem. Many people go about it in different ways. What I usually do is not a common practice. I create a template for a machine, a VM machine, with a pip requirement list, have a CI/CD pipeline to create that template, deploy it. Okay. You can even use Airflow to deploy that instance, bootstrap it, and then run your pipeline. You understand? That really depends what you're trying to achieve. If you're trying to create a machine,
I'm not familiar with this and the all CI/CD methodology.
Yeah, it's a complex answer, this one. There's several ways to go about it. One is to create a dedicated machine that has only the pip packages you need, and it will be external to the Airflow cluster. That's one approach, the naive approach, call it. Second approach will be to call an operator of Python operator that uses virtual env. I forgot the name. You can Google it, and then it will set up the pip requirements for you. I haven't used it myself.
What is the name of this operator?
It's some sort of permutation of Python operator. For example, Python virtual operator or something like that.
Okay.
If you don't find it on Google, contact me via email. The third option would be containers. Kubernetes Executor, and then on each container that runs, you'll be able to specify the degree of freedom you need. I personally hate this solution because it complicates
I'm not familiar
everything.
with Kubernetes, so.
Yeah, so avoid it. So use an external machine to the cluster, run what you need.
So you say you'd create a virtual machine with only these DAGs and operators?
Only with these pip packages. And then I connect from the Airflow to this external machine where I run what I need and come back to data pipeline.
No, but I was asking how can I install with pip, like take DAGs and in the all of the Airflow architecture. I mean, with the custom folder in the plugin folder in the Airflow home, and check all the dependencies.
I don't have a good answer for that. I don't have a lot of experience with custom operators. It's usually a DevOps packaging issue. You need to consult with the DevOps expert that writes a lot of Jenkins pipelines. He may have a better answer than me.
Okay.
I apologize, but I don't do custom.
Yeah,
operators a lot.
I know. I have hard questions now.
No, it's okay to have hard questions, but I base my answers on my experience, which is far from being perfect. I help as much as I can. Sorry.
No, that's great. Thanks.
Okay, guys. So basically, any more questions before I wrap it up? Okay, so we just want to conclude by asking again why Airflow. Usually Airflow is a good solution if you want to go custom, if you want to go vendor agnostic, and you want minimal cost for this data pipeline. If your use case is very complicated, if you're performance conscious, and the market has spoken. I mean, if you switch companies, it's really likely that you're going to use Airflow again. Data engineering, for example, in my philosophy, it's all about making faster, cheaper, simple data pipelines. So the good data engineers should have performance, cost, and simplicity of maintenance in mind. So the reason we learned this class today is because sometimes you want to achieve everything. Faster response time, faster, very cheap and simple maintenance. It's like a triangle. Not always you can get 3 out of 3. You can take sometimes these two, sometimes these two, and sometimes these two. If you get 2 out of 3, you're good. If you get 3 out of 3, it's extraordinary. So just to recap, what will make your Airflow cluster faster? It's all about configuration, CPU cores, and proper resources on your Airflow DB, and good practices. Don't forget to monitor. If you're talking about cost reduction, use local Executor or Celery cluster and with less nodes. Simplicity, local Executor and avoid containerization, and scale up your cluster node, meaning less nodes. Just call to action. You can access all the Airflow blogs in our website and review our meetups. Please, 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 if you're still here and bear with us this entire hour-and-a-half session, please subscribe to our YouTube channel. This will help grow our community. There's no commercial issues behind this. It's just, for the community to help and share knowledge. Feel free to connect to the other meetups. Contact me in any way you feel fit. Please add me in LinkedIn. I would be honored to be your LinkedIn buddy. And that's it.